Hi you guys! Today we're going to talk about chemical reactions. Before we begin, make sure you have a highlighter, a pen or pencil to write with, your notes printed out, and you will also need a periodic table. Pause this video and get your stuff together and unpause it as soon as you are ready. So let's get started with the chemical reactions. In this unit, you will learn about different types of chemical reactions and how to write them. There are a total of 5 different chemical reactions you will be learning about. So let's get started. With the components of a chemical equation. Reactants are the chemicals that the reaction starts off with. So I have a chemical equation written right here. The reactants would be anything that shows up before the arrow. It could be elements, molecules, or compounds. The product is the chemical that the reaction produces. So anything that shows up after the arrow are your products that the reaction produces. Coefficients tell you how many molecules or formula units are present in either the reactants or the products. So this number 2 right here is the coefficient that is for hydrogen gas. This tells you that there are 2 molecules of hydrogen gas. Compared to oxygen, there isn't a coefficient in front. However, there is a coefficient of 1. The 1 is just not written because it is understood. So even though it looks like there isn't a coefficient, there is, and the number is 1. So there is a total of 1 molecule of oxygen gas that is present. Now, if you look at each of the elements and molecules in this particular equation, notice that there are descriptors that are present. Descriptors describe the state of matter for each of the species. So for a hydrogen gas, the G stands for gas, the L for H2O stands for liquid. You also have something called aqueous, and the symbol for that is AQ. Keep in mind that the word aqueous means mixed with water. And then the lowercase s would stand for solid. Now let's talk about a chemical change. A chemical change is a process in which new substances with new properties are formed. And this is done by breaking or forming chemical bonds. Keep in mind that whenever a chemical bond is broken or it is formed, you either have a transfer of electrons if it is an ionic bond and compounds are involved, or the electrons will be sharing electrons to complete that octet. And that is true for any covalent bonds or molecules that are present. There is visible evidence of a chemical reaction. The evidence is either you will have some kind of formation of gas, a color change, formation of precipitates, or you will have a temperature change. But either way, there is actual visible evidence of the chemical change. There are 7 diatomic molecules that you should know. You should have learned these 7 diatomic molecules in the covalent unit. However, if you didn't, these are 7 nonmetals that are very reactive. So in their purest state, these molecules actually exist as 2 atoms. And the mnemonic to remember these diatomic molecules is Hofbrinkel. Okay, and that is to say that you have hydrogen is H2, oxygen molecule, nitrogen molecule, that is N2, fluorine molecule, F2, chlorine molecule, that is CO2, bromine molecule, that is Br2, iodine molecule, that is I2, and of course oxygen, O2. So you do need to memorize this. You need to know this in its entirety. So memorize. Okay? You need to memorize these 7 diatomic molecules. Let's talk about balancing equations. There are certain steps that need to be done in order to balance an equation. Balancing equation is really all about bookkeeping, and you will see that in a minute, that it is all about bookkeeping. But the very first step is that if you are given a chemical equation, you need to be able to predict the product. Okay? And then you need to assign the subscript to either the molecule or the compound that is present. Don't forget that if you have diatomics, those diatomics are always two atoms, so you need to either write H2, O2, N2, and so on. The only place for balancing equations that you can add is in the coefficients. You cannot add in the subscripts. The subscripts have to do with the formula that is written. If you start adding subscripts right here, or start taking away these subscripts, such as this 2, you are actually performing atomic surgery. So that's a big no-no. You cannot do that. The only place where you can add ever when you're balancing an equation is right here in the front of the formula. So not in the middle, not as a subscript, but only in front of the entire molecule, formula, or element. Okay? So let's begin. So you've got a compound here, and we want to be able to balance it. So I've got a sheet of paper, and I'm just going to take a moment and copy this equation, because I'm going to need a little bit more space than this. Okay, so I rewrote my formula. So I've got sodium bromide reacts with fluorine gas to produce sodium fluoride and bromine gas. And I know the state of matter for each one of these. So when I am balancing equations, it's all about bookkeeping. It's about keeping the number of atoms the exact same number in the reactant side and the product side. So what I'm going to do is I'm going to list all on my reactants as well as on the product side, all the elements that I have. So I've got sodium here, bromine, and then I've got fluorine. So since I am going to be keeping, since I'm bookkeeping, what I'm going to do is that these same elements are actually present in the product side. So I've got sodium right here. And then the next element that I have is not bromine, but it is fluorine. Don't worry about that. What you want to do is you want to keep your bookkeeping as easy as possible. So just since there is a bromine, go ahead and make bromine the next one. And then since there is a fluorine, that's your third element that you have there. Okay, so you're always trying to balance the number of atoms for each element. So there is a number 1 here, and you can take that coefficient and multiply it by your subscript that is also there. So 1 times 1 would give us 1 sodium atom. 1 times 1 would give us 1 for bromine. 1 times 2 now would give us 2 for fluorine. 1 times 1, 1 times 1, 1 times 2. Okay, so we've got this. Okay, so notice here that the sodiums are balanced. That's good. Our bromines are not balanced, and neither are fluorine. So the only place where we can add is right here, the coefficient. So we're going to add, in order to, there's 2 over here and 1 bromine. So I'm going to go ahead and add on the product, on the reactant side. This would make my sodium now 2 and my bromine 2 also. So the bromines are balanced, but my sodium is not, and neither is my fluorine. So we're going to go back to the reactant, to the product side. The reason why I go to the product side is because I cannot add any more here. This is already, the scale over here is a lot heavier than the reactant side. So I'm going to go ahead and add in my, is a lot heavier on my product side. So I'm going to add to my products. So I'm going to add here, I've got fluorine, which is 1 fluorine. So I'm going to put a 2 right here. And this 2 is now going to make my sodium 2 and my fluorine 2. By doing that, I am now balanced. My sodiums are balanced, my bromines 2 are balanced, and my fluorines are also balanced. So everything is balanced. And so I'm going to go back to my notes here. And I am going to put in my notes 2 compounds for sodium bromide and 2 compounds for sodium fluoride. Okay, so I'm going to put a 2 and 2, if you did it on a separate sheet of paper. The next chemical reaction that I have is actually a hydrocarbon reaction. So I've got ethane right here that is reacting with oxygen to produce carbon dioxide and water. This is actually a combustion reaction. So your combustion reaction always has your hydrocarbon that is reacting with oxygen. So whatever your hydrocarbon is, you know in a combustion reaction, it's always oxygen that's in the reactant, and in your products, you're always going to have carbon dioxide, CO2, and water that is always produced. Okay? Okay, so I've got my combustion reaction written right here. So again, just like I did for the first one, I am just going to list all of my elements that are in this chemical equation. So I've got carbon, hydrogen, and oxygen. It doesn't matter that they're not in the same order on the product side. For bookkeeping's sake, I'm going to keep them the exact same because there is a carbon here, there is a hydrogen here, and there is oxygen also present in the product side. Okay, so I've got 2 carbons. I've got 6. 1 times 6 is 6 hydrogens. 1 times 2 is 2 oxygens. 1 times 1 is 1 carbon. 1 times 2 is 2 oxygens. 1 times 2 is 2 hydrogens. And then I've got 1 times 1 is 1 oxygen. But I already have oxygen here, so it's 1 plus 2. That would give me a total of 3. 3 oxygens that are truly present. Okay, so I'm going to try to balance my my carbon first. You always want to try, whether it's a hydrocarbon combustion reaction or any other reaction, your hydrogen and your oxygen are usually the last few elements, the last elements that you balance. So, and usually it is hydrogen that is the very last element that you should balance. Try to balance all the other elements first before you get to oxygen and then hydrogen at the very end. Okay, so we've got carbon. We're going to put a 2 right here, see if that helps. So it's 2 carbon. 2 times 2 is 4 oxygen plus 1. That would make it a total of 5 oxygens. I'm going to go ahead and balance my hydrogen also. So it's a 6 in the reactant, 2 in the product. So I'm going to add to the product side, and I'll put a 3 here to make it now a total of 6 hydrogens. 6 times 1, 3 times 1 gives me 3 oxygens, plus 4 oxygens right here, which gives me a total of 7 oxygens. Okay, so I'm pretty much balanced now. Everything, the carbon and the hydrogen are balanced. The only thing that is not balanced is oxygen. And notice, you guys, that the oxygen that is present is actually present in the product side. This is true for all combustion reactions. If you ever get to a point in your combustion reaction where your carbon and hydrogen are balanced both in the reactant and the product, and your oxygen in the product is an odd number, then that odd number becomes the coefficient of the oxygen in your reactant. So we're going to put a 7 here, and then you're going to double everything else except for the oxygen. You're going to double up all the other coefficients of all the other molecules that are present. There is a 1, so 1 double of 1, 1 plus 1 would be 2. So you double that. Keep that 7 there, but you've got 2, double that, that would be 4. And then double the 3, that would make it a total of 6. So that's just a little small trick that you should learn about hydrocarbons. So now if we go back, this is 2 times 2 is 4. 2 times 6 is 12. 7 times 2 is 14. 4 times 1 is 4. 4 times 2 is 8, plus 6. That makes it a total of 14. And then we have 6 times 2 is 12. So we are balanced: 4 carbons, 12 hydrogens, and 14 oxygens. So we are now balanced in this case. So we're going to go back to our notes, and in our notes we're going to write that we have 2 molecules of ethane, 7 molecules of oxygen, 4 molecules of carbon dioxide, and then 6 molecules of H2O that are present. With these number of molecules that are present, now our reaction can move on. Okay, so the last thing that I want to talk to you about balancing equations is when you have polyatomics. So if you have a polyatomic, it is best to consider the polyatomic as a unit and balance it as a unit together. Okay, so what I am saying in this case is that you have ammonium here, NH4. This is a polyatomic. Your PO4 is also a polyatomic. So rather than trying to balance nitrogen, hydrogen, phosphorus, oxygen together, rather than trying to balance that, you're going to take this as ammonia as one unit, phosphate as another unit. So in our case, if we decide to write this, we have ammonium, phosphate, and then we have silver, which is an element, so we're going to keep it as it is, and then this nitrate. So you're going to balance these as a single unit. The same polyatomics should be present in your product, and notice that they are. You've got ammonium, you've got phosphate, you've got silver, and you've got nitrate. So right here, if I go back up, pull it up for you, you've got the nitrate. So you've got the exact same polyatomics and element in your product side. So for bookkeeping's sake, just copy it as it is onto the other side. Okay, so you're going to balance each unit individually. So as far as ammonia goes, there is one coefficient. So you have one molecule of ammonia, but then there's this 3. So 1 times 3 gives you 3 ammonium ions. 1 times 1 for phosphate, since there isn't a number here, it is 1. 1 times 1 for silver is 1. 1 times 1 for nitrate, since there isn't a number outside of the parentheses, so we're going to say there's 1 nitrate. Okay. 1 times 3 gives us 3 silver. 1 times 1 phosphate gives us 1 phosphate ion. 1 times 1 for ammonium. 1 times 1 for nitrate. Okay, so you can see that we need to balance basically everything on here. So if we try to balance everything, that would actually result in, let's see, let's put a 2 over here, a 3 in front of the ammonium and nitrate. So if we put a 3 there, that makes our ammonium 3, and then our nitrate, 3 times 1 is also 3. Okay. Now let's go back and try to balance over here. Since we've got ammonium, that is 3. Our ammonium is balanced. That's good. Our phosphates seem to be balanced. Our silver, on the other hand, you've got 1 in the reactant and 3 in the product. So we're going to put a 3 right here to see if we can balance it. That makes it 3 silver atoms, and 3 times 1 makes it 3 nitrate ions that are present. Okay, so now our ammoniums are balanced, our phosphates are balanced, our silver element is balanced, and our nitrate ion is balanced. So everything is balanced in this case. It's always a good idea to keep your polyatomics as a single unit. If not, then you would be balancing a lot of these elements individually. You would be balancing nitrogen, hydrogen, phosphate, oxygen, silver, and nitrogen. And that becomes a lot of elements to balance. If you can make it somehow, put these as units to help you balance, that is the best. In polyatomics, you usually get a break on. Okay, so let's move on to our notes. Okay, so moving on with our types of chemical reactions. The very first type of chemical reaction that you are going to learn about is called synthesis. And it is exactly what the word synthesis means. It means to produce or form something. So what you are trying to produce or form is from whatever the reactants are. You're putting those two reactants together to form a compound. So for a synthesis reaction, The simplest of these reactions occurs when two elements combine to form a compound. That can certainly happen also, not only with a compound, but with a molecule also. So it's compound and molecule. So this depends on the type of bond it is. Okay, so you've got an example here. You've got two molecules of hydrogen. So we've got H2. Each molecule of hydrogen has two atoms attached to it. You've got two of those molecules, so it's 1, 2. You've got one molecule of oxygen gas, which is a diatomic. So you have oxygen gas, diatomic, 1, 2 elements, but only one of this oxygen gas to produce right here two molecules of H2O. H2O is oxygen in the middle, hydrogen on the side, so 3 atoms, and you've got two of these molecules, 1, 2. So this is a synthesis reaction where you have two elements, 2 elements that combine together to form a compound. Okay, and that is the most basic type of synthesis reaction. Okay, now another type of synthesis reaction that you have is that you have an acid. We'll go ahead. An acid that is produced by adding a non-metal oxide to water. So if we look at our reaction over here, sulfur, as you can see, is a non-metal. It is located on the periodic table. So if we're looking at our periodic table, let me see if I can zoom out a bit. Okay, if you're looking at the periodic table, sulfur is right here. It's a non-metal. So whenever you have a non-metal oxide, sulfur and oxygen are together, that's mixed in with water, you are always going to get an acid that is produced. So you have here sulfuric acid that is produced. Keep in mind that whenever we are talking about the states of matter, your acids will always have an AQ because they're always mixed in with water. Okay. On the other hand, a base will be produced or synthesized whenever you have a metal oxide that is mixed in with water. So what that means is, again, you have oxygen that is present, but now you have a metal. So on your periodic table, looking at your periodic table, that could be anything from group 1, group 2, your transition metals, even your intertransition metals. All of these bonded to oxygen will eventually produce a base. And you know it is a base because your base will always have a hydroxide group attached to it. Just like the acid, your base needs to have an AQ where it is mixed in with water. Okay? So, and you're always balancing your chemical equation. In this case, you've got potassium, 2 potassiums, 1 potassium here. So if you want, and if this helps you out, then certainly continue with the bookkeeping to help you out. If you feel like you are past it, you don't have to, and you can just simply freehand it. So you've got 2 potassiums, 1 oxygen, and 2 oxygen right here. But we 2 hydrogens right here. We also have another oxygen, so it is 1 plus 1 would give us 2 oxygens right here. 1 potassium, 1 oxygen, and 1 hydrogen. So we need to balance it. We need to put a 2, so we're just going to simply put a 2 right there, and that should help us out. We've got 2 potassiums, 2 oxygens, and 2 hydrogens. So now we are a balanced equation. Okay. Moving on now to a decomposition reaction. Decomposition is exactly what it sounds. These are reactions that usually take place under high pressure, high temperature, or high temperature conditions or electrolysis. And decomposition is exactly as the name says. It is all about breaking up the reaction. Okay, so synthesis is all about formation. Okay, and decomposition is all about breaking up. Okay, you're decomposing, you're breaking down your reaction. So you start off with a compound or molecule, and now you break it down, sometimes into its most fundamental elements, sometimes into the more simple compound or molecules. Okay, so it just depends on what kind of decomposition reaction there are. There are, as you can see, a total of 5 decomposition reactions that you will be learning. I highly suggest you guys that you learn each one and understand how to write the chemical reaction. This is going to come back a lot. We talk about decomposition, and really any one of these reactions is game. So it's fair game. So even for synthesis, know how to write your simplest synthesis reaction, but know how to write an acid and a base synthesis reaction also. Okay, so moving on, you've got your binary decomposition. A binary decomposition is when it decomposes into its most fundamental elements. It often is produced by electricity currents that are flowing through the substance. Okay, the example that I have for you, and we usually use electrolysis to break up water, is that you have 2 molecules of water, liquid water, and you take this water and you connect it to electricity, and electricity causes this water molecule to break up into hydrogen gas and into oxygen gas. Okay, so you've got a molecule that breaks up into its 2 fundamental elements, so this is a binary decomposition. The next kind of decomposition is called a carbonate decomposition. So yes, you do use your carbonate ion, polyatomic ion in this case. And the metallic carbonate produces a metallic oxide and carbon dioxide. So if I give you a metallic carbonate, that means I can get you, it could be a metal that's from the group 1, group 2, your transition metals, or even your inner transition metals. It doesn't make a difference where this metal is from. So in our case, I'm going to use calcium as our metal. So you have calcium carbonate. That is a solid. And calcium carbonate, when it breaks up into the metallic oxide. The metal in this case is calcium, so it'd be calcium oxide that it breaks up into. Now keep in mind that you've got to use the oxidation numbers to write the correct formula of your metallic oxide. And also carbon dioxide, which is CO2. Okay, carbon dioxide is a gas, calcium oxide is a solid, and your calcium carbonate is a solid also. These are balanced. 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 1 oxygen plus 2 oxygen makes it 3 oxygens. So we are now balanced. Okay, so your third type of decomposition reaction is what we call a hydroxide decomposition. And a hydroxide decomposition, just like the carbonate, is a metallic hydroxide, however. It's a metallic hydroxide that produces a metallic oxide and water. So the products for this is metallic oxide, but now you are producing water. So very similar to this. So you've got a metallic hydroxide. I'm going to use 10. I'm going to use 10-4 for my metal. So I'm going to get here 10 hydroxide. And this is a solid. That will produce now 10-4 oxide, which is a solid also, and then water, which is H2O. Keep in mind that water is always a liquid. And now let's see if we can balance this. We have 110, 110. 4 oxygens, 2 plus, you can put a 2 right here. 2 plus 2 makes it 4 oxygens, 4 hydrogens, 2 times 2 is 4 hydrogens. So yes, that 2 does belong there. So now it is balanced. Next one you have is chlorate decomposition. And this is again a metallic, but now it's a chlorate, metallic chlorate that produces a metallic chloride. So that's a little different with oxygen gas or oxygen molecules that is present. So in this case, I'm going to pick a metallic chlorate. Chlorate, remember, is your polyatomic, just like hydroxide and just like carbonate. These are all your polyatomic ions. So chlorate in this case would be ClO3 minus 1. So I'm going to pick sodium chlorate, and that is a solid. That will produce a metallic chloride, so it's sodium chloride, plus oxygen molecule, which is O2. Okay, this is a gas, this is a solid, and then sodium chlorate is also a solid. We want to balance 1 sodium, 1 sodium, 1 chlorine, 1 chlorine, 3 oxygens, 2 oxygens. So we're going to put we could put a 2 there, but it's hard to balance that 2, so we're going to put a 3 here. So now this gives us 6 oxygens. So I'm going to put a 2 right here. 2 sodiums. I'm going to put a 2 for sodium, 2 sodiums, 2 chlorine, 2 chlorines, 6 oxygen, 6 oxygen. Okay, so we are now balanced with this, and if you look at this, you've got the 2, 2, and 3 coefficient, which are on the lowest common denominator, so you do not need to reduce it. You're going to keep it as it is. So the chlorate decomposition is balanced here. The last reaction we're going to look at is peroxide decomposition. Peroxide decomposition starts off with the metallic peroxide. Keep in mind that the peroxide is O2 with a 2 minus charge. And this produces a metallic oxide and an oxygen. So the metallic oxide that you have, we're going to start off with chromium peroxide, and this is going to be chromium 3 that we have. So in our products, the metal that we have is also going to be the same oxidation number as what was in our reactant, and that is going to be chromium 3. So this chromium in the product will have an oxidation number of 3 also, just like in the products. Okay, so we're gonna, this is our equation, produces Cr2, O2 with a 3 outside, and this is a solid. Metallic oxide, that's a solid, and then oxygen molecule is a diatomic, which is a gas. Okay, so we're gonna start off with this. Most of your diatomics are usually gases, exception with bromine and iodide. Iodine would be your solid and bromine would be your liquid. Okay, so we're going to start off with the balancing here. 2 chromiums, 2 chromiums, 3 oxygens, 3 oxygen, 2 times 3 is 6, so 6 oxygens. Times 1 would still give us 6 oxygens. This is 3 plus 2, which would only give us 5 oxygens. So we still need to balance this out. We're going to balance it out by putting a 3 over here. So I'm going to put a 3 here. This gives me 6 oxygens. I've got the 6 oxygens now and the 2 chromiums. So this is 6 oxygens, but I still have this 3 right here. So I need to balance that out. Put a 2 for the chromium, so that makes it 4 chromium. Put a 2 right here, and that'll make it 4 chromium. Now I've got 2 times 3 is 6. 6 times 2 is 12. So I've got 12 oxygens in total. 2 times 3 is 6. Plus, I've got 6 right here. 3 times 2 is 6. So 6 plus 6 will give me my 12 oxygens now. So I am now balanced with this equation also. So my biggest advice to you is that when you were learning how to write chemical reaction, it is really important that you guys learn the type of reaction it is and how to write that reaction. For example, the carbonate decomposition will always have the metallic carbonate, a metallic oxide, and then it will have carbon dioxide. Where versus peroxide, you will have the metallic peroxide that will produce a metallic oxide, but you will have an oxygen that is also produced. So keep this in mind for both the decomposition and synthesis reaction. Okay? And this concludes my lecture for today, and I will see you guys later. Bye.